Thank you all for staying till 4. I was worried I'd be by myself here to present, especially with this compelling topic of creating unified views of data with semantic graphs. So let's go into it. And this is brief. I don't have a ton of time to get into a lot of depth, but I want to at least talk about the starting points and make sure everyone walks out of this room with a good understanding of what we mean by semantic graphs, what an ontology is, and some of the interesting things you can do to help improve findability of both content and data using ontologies and semantic graphs. So let's start with what is an ontology, because that's one of the building blocks to what we're doing here. And an ontology, as we've defined it, is a defined model that organizes structured and unstructured information. Very important that we're talking about both. Through entities, those people, places, and things that really draw everything together. The properties about them, and the way they relate to one another. So we think about how do they interact together. And when you pull those things together, that's what an ontology is. And when you're creating a graph database, that ontology is the starter point. For those that are familiar with kind of relational databases, it's that ERD model. That ontology is what you're doing there to define your database. And these are hot right now. And if you have any question, I think every one of you sees the results of a graph database almost every day. Every time you search on Google, you get the Google Knowledge panel. How many people have seen that or know that that's from a graph database? Okay. Take a look, search for a person, place, or thing, and you should see that when you move forward. So this is stuff a lot of companies are doing. Places like Google have found it to be very valuable as a way to pull together disparate sources of information. So what we want to do when we talk about a semantic graph, why do we use it? Typically, you've got structured data and unstructured information. You've got that content that we all talk about. And this is always kind of the holy grail. How do we pull these together and really derive real meaning from it? This has been something we've talked about in KM for, well, as long as I've been doing it. And I'm told I look younger than I am. So I've been doing this for 25 years. This is something that's been going on for quite a while. And so I'm going to give you, as we move forward, 2 examples of how this is done and how we're able to pull disparate information sources together to create that unified view of information that's meaningful, graphs and charts, the kind of stuff where you can do real analytics off of it. So example number 1 is Boehringer Ingelheim. I think that's how you pronounce it. I've always struggled with this one. I'm going to call it BI because that way I won't mess it up. So BI needed a better way to understand the value of the research they were doing. So they had, they were doing research, they had some information, but they couldn't understand across all their properties and all of their, all of the different disciplines and groups that were working, how valuable is our research? Is this working? Because we're investing a lot of money in it. And so they came to Semantic Web Company, makers of Pool Party, and said, how do we fix this? And they said, well, a semantic graph will help. And so what they did is they used Pool Party software to define a semantic graph that associated journal articles, divisions, impact assessments, which is an important measurement. I don't know if you're in the journal space, an impact assessment is a figure that's calculated based on how often your journal's cited. So it's a sense of how valuable is this journal article, right? And then they wanted to know, based on location, topic, et cetera, how is this being used and how valuable was it? So what I'm going to do next is take you through a short little video showing what they built, and we'll talk through how it worked. So this is the BI publication tracker. This was the end system that they put together. This was, as you'll see, it's a search, but it's also a way for BI to start to understand the value of their journal articles, hence the results of their research across all their different properties. So let's take a look at how this works. So classic search box, so you can search for topics and ideas, right? And then as we scroll over to the left, as you would expect, your classic faceted search, different categories like the journals, the business unit, et cetera. All of this was captured through the pool party tool. And then as you look at search results, they started to look at how valuable was it, right? So in the search results, you could see this was blogged or tweeted or it was re-referenced. So they had a ways of associating not just content, but numeric information with it. So they could start to score this stuff. And that's why, as you see, there's a graph at the top of this. So let's take an example and play with one. And we're going to search for something I know we'll have some answers on, which is, unfortunately, cancer. So you'll see we had about 5,000 journal articles. And after we execute our cancer search, we're down to just short of 300, right? So we've filtered out results, and we're still getting graphs and charts that define what we're getting from it. And you'll see the filtering is done by search, as you would expect. You see the classic hit types. These are the things that have mentioned cancer. So that's good and interesting, but maybe I want to look at this a different way. So maybe I want to say, so how many divisions are publishing information about this, or which divisions? And you'll see as I come and select by division, I'm able to see that over 50% of the journal articles that are published that mention cancer come in the medicine division, right? So that tells me that's where our research is focused, and it's a great way to see that. So next I might ask myself, well, which organizational groups are doing this, right? Help me understand that. And you'll see here, when I look at that new chart, I'm able to see that the leaders are all about the same. There's no one kind of outperforming anyone else. But this is information I wouldn't have had by looking at a bunch of journal articles. And I can go to the next step and say, well, how often does this happen by year, right? And now all of a sudden what I see is, wow, we've really started investing a lot in 2017 on cancer research. So something triggered that. I don't know what, but BI cared about that. And then the other years are slower, but you can see how I can start to take that really journal content and start to add structure and value and start to come up with charts and reports and results on that. So that's example one, the BI publication tracker. And thing to remember there is that's about content. Now we're going to talk about a unified view of a semantic database that has no content, because you don't need content to do this. It's not just about content. And of course, it's last day on the conference, so we have to talk about something a little more fun. Thought we'd use Pool Party's Wine and Cheese Recommender. Anyone interested in this? It's actually, the link to the site is up there. We'll be posting this. It's kind of a fun little system, and I'm going to show you how it works. So let's get started. Just as you'd expect, we have that same search interface. We have descriptors about wine, and these are kind of common descriptors you'd see about wine. The same thing with cheese, right? So these are the different types. And then as we go below, we have a list of wines and cheeses, and there's only about 113 now, so it's not complete. But if you like this and people get excited about it, we'll add more, right? So what I want to do is start by picking a wine, and I happen to like Cabernet Sauvignon. So let's go take a look at a Cabernet and see what we have. Well, there's only 113 wines, so we have 2 to pick from. And I'm going to start with the Cuvée, and we're going to open that up and start to see. Now we've come down to, for those that know the ontology space, we're going to be looking at the entity wine, right? So I pop in and I'm looking at the Cuvée, and look what I've got. I've got the mentioned name of Cuvée, all the recommended cheeses that go well with this. And then on the right-hand side, I have all the wines that I could replace with. So these are very similar. And then as we dive in and we look at this, you'll see I've got an entity type. Well, this is one of those entities, those things we've talked about, and it's wine. And then underneath that, I've got descriptions about these are the characteristics of the wine: medium tannin, full body. You've all seen this stuff before. Well, what I want to do, and remember this, I know it's late in the conference, but I need your help. Remember medium tannin, because we're going to talk about how this whole logic is done through a unified view. Right? So next I'm going to go and look at the Purano cheese. And now I'm looking at a cheese entity. Right? And if you remember, we talked about how are these relationships exist. So as I look in at the cheese, of course, I get to see all the wines that match with that cheese, as well as other cheeses that could be replaced. So I'm really thinking about relationships here. And then as I go in and look at the descriptions of this cheese is It's, well, it's higher fat, unfortunately, and semi-hard cheese, and that's going to be the one we're going to remember. So medium tannin and semi-hard cheese. Remember that as we go look behind the scenes. So as you'll see, we've looked at a cuvee and the Prano cheese that matches with it. So I'm going to close this down, and now it's time to go behind the scenes and take a look at how the system actually figures this out. For those that aren't familiar with this, this is Pool Party, classic taxonomy on the left-hand side. You can see cheese and various cheeses. This is stuff, if you've been at taxonomy boot camp or ever worked with these tools, this is some of what you see. And nice interface for looking at it. What we're going to do is I'm going to simplify this and show you that there's really 3 taxonomies we're starting with: cheese, wine, and those flavors and characteristics that associate the two. So now, looking behind the scenes inside the administrative console, let's see what our wine is. So it's a red wine. It's a Cabernet. Right? And there's my cuvee. Come on. There we go. And what I see here is, this is called SCOS. It's a basic taxonomy structure piece. But more importantly, what we've done is we've created a custom ontology for this called the super cool harmonizer schema. So let's go look at that. And the first thing I see is these are the characteristics of that wine, right, of the cuvee. This is the same thing we showed you before on the main screen, right? These are, that's what we've got. So I've defined this entity of wine and this particular wine, and these are the characteristics it has. So let's go look at that cheese behind the scenes as well. And I know only from going through this demo that it's a Dutch cheese, that Prano is, not a cheese expert. And as we look at Prano, again, I've got a nice hierarchical structure to help organize and define that, and I'm going to look at my magic harmonizer schema again. When I go here, these are the characteristics we saw before, and these are the ones that are associated with the cheese. So now you know what I called out before. You can see behind the scenes how this stuff is stored. These are attributes and relationships. So the next thing to do is, why are they related? How did this system know that these go well together? And to do that, I want to look at the characteristics and flavors. And you'll remember I highlighted medium tannin. So as we go to medium tannin, just like we had before, simple taxonomy, and this is how ontologies can grow. But now I go to the magic harmonizer schema. And when I go here, it lists all of the wines that have that medium tannin association. But if you also look down at the bottom, anything medium tannin goes well with semi-hard cheese. That's the relationship. So when I click that relationship, I now can see, I'm bouncing around in Pool Party, all the different cheeses that are semi-hard. So I know these are all related, right? And when I click on Prano cheese, I come back and I see my cheese. So what we've done, as you look at this, and I'm going to kind of reopen this and show this back to you again. Here's our wine. Its descriptor is right there, medium tannin, as we had seen. And when I pick the cheese, its descriptor is semi-hard. So what happened behind the scenes is we defined the ontology and the relationships, and the system was then able to pull this together. What's interesting is by doing one small relationship like that, we can handle thousands of wines. Talk about scalability. This is where these systems using these ontologies and the unified views allow you to pull information from a lot of sources and start to spot relationships you wouldn't have understood otherwise. So that's kind of a brief 15-minute overview of what we're doing. Any questions? Here we go, end of the conference.